All right, so this question asks us to determine the surface area of the composite object to the nearest square foot. So remember, composite object means that there's two or more distinct or separate pieces that we have to consider here. And so I think it's pretty obvious that we have a cylinder, which is this part right here, right? That's the cylinder, and we're going to find the surface area, the outside wraparound part of that. And then you also have the hemisphere. So this is a half of a sphere. So we need to find the surface area of this piece here. So we have two parts to it. Okay? So the surface area is going to be the surface area of the cylinder, and I'm going to put a little star there, okay? Because we have to consider a couple things, plus the surface area of the hemisphere, and a little star goes there. Now, what is it about surface area that we have to be careful about? It's not quite the same as volume. Volume, you just find the volume of one, find the volume of the other, and add them up. But what is it about surface area that we just have to be very careful about?
Not all of the shape is showing.
Thank you. Very good. Not all of the shape is showing. Not all of the shape is actually an exterior surface. So for example, if we were to take a knife and to cut the top off of this thing, you see there's a kind of a bottom side of this hemisphere, like this flat side here, that is not exposed right now. So we have to be careful not to count that. Also, that same portion right there, that's the top of the cylinder. So we are going to count the bottom of the cylinder, yes, but we're not going to count the top of the cylinder because it is covered up by the dome. You see that? Okay, so when you're doing these questions, some of them are a little complicated, and you got to make sure that you don't count the area that's not exposed. All right, so that shouldn't be a big deal. Let's see if we can figure that out. So the surface area of the cylinder is going to be what? What's the formula for surface area of a cylinder? Well, we need to have this bottom piece, so that's pi r squared, and we also need to have the area of the wraparound part, don't we? And so what is the formula for that? Okay, pi r squared times height. Now you got to be careful. That's actually volume.
Oh.
Right? Okay. That's okay. I'm glad you said that. We got to learn from that as well. So the net diagram, this might be helpful. I will erase this later, but the net diagram of the cylinder, when you unwrap it, okay? When you unwrap it, it kind of looks like this, and of course this is 4 feet. That's the height. And what is this length right here? Well, this length is actually this. So how do you represent that in a circle? You remember? 2 times pi times r. Yes. So the area is going to be 2 pi r times the height. Okay? Plus 2 pi r h. So again, that is the area of the wraparound part of the cylinder. All right, so what about the second part, the surface area of the hemisphere? What do we remember about the surface area of a sphere? What's the surface area of a sphere? Who remembers? 4 pi r squared, right. So 4 pi r squared is the area of a complete sphere. This is a half of a sphere, right? So we just do that and we just divide that by 2. Now remember, we don't have to worry about this because it's actually not a part of this formula. Right? So we're not double counting this by doing 4 pi r squared divided by 2. Does that make sense? Okay. Okay, so here we've got our formulas, kind of a plan. So let's enact this plan here. So pi, what's the radius? What was it? So 2 feet there? So pi times 2 squared. That's the area of this base here. Plus 2 pi times 2 times the height is 4. Now 4 over 2 we can simplify. That's just 2 times pi times 2 squared. Okay? Does that look okay to everyone? All right. And so this is going to be 4 pi plus 16 pi plus 8 pi. So 2 squared is 4 times 2 is 8, and so on. 2 times 2 times 4. So this actually is 28 pi. Now that's the exact way to write that answer, actually, because pi is irrational. So I think that they ask you just to round to the nearest decimal. But in the future, when we talk about exact values, you would actually, this would be your answer, 28 pi square feet. Right now, I'm going to get you to write the actual answer as a decimal, because they say to the nearest square foot. So this would be okay, acceptable answer, feet squared. So let's do this. Let's get our calculator out. Okay. Was there an error there? Are you see it? Yeah.
Oh, she was saying the picture is different from the book.
This is example 2, right? Yeah, example 2. You're on the page there. Okay, so 28 times. Where's my pi button here? I should know where that is. Oh, right here. 28 times pi equals 87.96. 87.96. Now, to the nearest square foot is going to be what? 88. Okay. So that is the answer to this question, surface area of a composite object. Just make sure that you don't count the surfaces that are not actually exposed to the air. Think about this. The bottom is exposed, but the top part of the cylinder is not. Okay? So just a heads up here, for this question, if you're trying to find the surface area for this composite object, you need to find the area of this circle. You need to find the area of this wraparound part, but not the base, right? Don't find the base, because that's not exposed. You're also going to have to find the area of this side, of this bottom piece, this side along the back, this side along the other back side, and the base as well. And the one final thing, very, very important, when you find the surface area of this top part, I'll do this in a different color, the surface area of this top part, you again have to subtract the area of this circle. You have to subtract this out because it's covered up. So you see that? So you have this top part of the box, but because the cylinder is resting on there, you have to exclude that from the surface area. So not only do you not count it with the cylinder, you have to subtract it from the surface area of the top of this box. Okay? So you really got to think it through. You really got to think it through. Show all your work. Write your formulas. Do it a step at a time, and you should be able to do it. Okay? So this is. Let's see. Okay. So this is actually 3C in your assignment. Okay. So why don't you go ahead and do this one right now, just to make sure you know what you're doing with surface area. Okay. So take a few minutes, do this question, and I'll show you the answer in a minute.
Is it the assignment?
It's part of your assignment. It's the first question, yeah. So I've labeled all these exposed surfaces by numbers. The top part is 1. This wraparound is 2. The top face of this square prism is 3. And then the side is 4, 5, 6, and 7. So there's 7 surfaces. Now, what you have to just remember is that this part right here underneath the cylinder is covered up. So do you see how I did count it up here, but I actually had to subtract it down here. So it's kind of like that area 1, you don't have to count it at all, because it is included up here, but it's not included down here. Okay? So you could take all of those surfaces and add them up, and then subtract what's being covered up there. Okay, and the answer, I will show you the answer. I have the solution here. Let's see. So there's the question. Where is the solution? Where did it go? Okay, so just for another explanation here, the 2 pi RH, that would be number 2. That's area 2, 2 pi RH. 2 times the length times the width would be the top piece and the bottom piece as well. 2 times the height times the one side there would be 2HW, and that's front and back. And 2HL would be the height times this other dimension times 2. Now what they don't have in this line is the area of the circle, because they've subtracted it off, so it's not on there, right? And so this should be surface area. Anybody get 95.1 for a surface area for that? Okay. All right. So if you have a problem with that question, I can come around and give you a hand. But that's the first question in your assignment.